Hello guys, welcome back to the another data analysis core concept session where we are going to discuss about three main important topics, and the topics are modality, skewness and kurtosis. So let's start our discussion. So guys, you have already seen this diagram, but I haven't introduced the term modality on that particular time. Now you can easily make it out what actually the modality is related to. So basically modality used to describe the number of peaks within a given data set, and these number of peaks will define what kind of data distribution we are having within a given data set. If we are having a single peak, so that means it is a unimodal, and if we are having two peaks within a given data set, then it is become bimodal. And the third category of modality is the multimodal, where we are having the multiple peaks. So I'm hoping that you already know about what actually the significance of these peaks are, but if you don't know about the significance of these peaks, I will reiterate the point. So when we are getting the single peak, that means our data is normally distributed, and our 68% of the data which belongs to one standard deviation, and that standard deviation might be positive or it might be negative as well. As we already discussed about what standard deviation represent, it will tell us how far our data point is from the mean. In more simple term, I can tell that our most of the data point is near to the mean when we are having the unimodal. Now if we talk about the bimodal, that means we are having two peaks and most of the data points belongs to two different ranges, and such kind of shape you will get when you try to analyze count of categorical data. For example, if you want to identify that how many number of a student gets grade A and grade B, and when you try to plot the data, then you will find that belongs to the bimodal. So guys, this is about the modality concept which I wanted to discuss. So now let's proceed further and discuss about another concept called skewness. But prior to discussing about skewness, I just wanted to tell you, in this part of the course I am just focusing upon the concepts, or say core concept of data analysis, so that you should be aware about the terms which is being used while doing the data analysis. In this part of the course I try to avoid writing a single line of a code, because I want that you should first aware about the concept, then you can easily write the code and you can easily interpret what actually the significance of these concepts when you are getting the diagram within the plot. And now if you talk about how to draw these graphs or these plots of the given data set, then don't worry, we are having a separate section for data visualization within this course, and that section comes in next part. So now let's proceed further to the next topic, that is skewness. So guys, when we receive the data set, so our data, it doesn't generally comes into the normally distributed form. Most of the time we will get the skewed data. But prior to discussing about what actually the skewed data is, we have to understand that what actually the skewness concept is. So guys, skewness is the measure of how much the probability distribution of a given data set that deviates from the normal distribution. So now you must be asking that how normal distribution comes into the picture of skewness. So to answer your question, I would tell that if we are having the normal distributed data, then skewness should be 0, and their mean median mode belongs to the same point, and their left of the center and the right of the center looks symmetric. Now this is about the symmetrical distribution. Now let's talk about types of skewness and their significance. So basically we are having two types of skewed data. One is the positive skew and another one is the negative skew. So how do you identify that whether the given data set is positive skewed or negative skewed? You can identify with the help of plotting. If you plot the positive skew data, then you will find that most of the point belongs to the left side of the point. Another point you will notice over here in the positive skew data, where the tail is skewed on its right side, this portion I am talking about. Another properties you can check within the positive skew data is that when you calculate mean median mode of the positive skew data, then you will find that mean is greater than median and median is greater than mode. So now let's discuss about what actually the negative skewed distribution. So guys, a negatively skewed distribution is the distribution with the tail on the left side, like this image, and the value of skewness for a negatively skewed distribution is less than 0, and you can see it over here. Mean value is lesser than median value and median value is lesser than mode value. So to identify the negatively skewed data, you must have to remember this pattern. So when you plot your data set, then you will get such kind of histogram as well as KDE plot. KDE plot mainly refer to the kernel density plot, which will be generally used to identify the distribution of the data, to get the idea about how this data is distributed, whether the data is positive skewed or negative skewed, or it is normal distributed data. So guys, this is about the skewness of the data. Now you must be asking that how does it matter if my data is positive skewed or negative skewed? Then I would tell that when we proceed to the next step, where we are doing the data modeling with the help of predictive analysis, and if we provide this skewed data to our data model, then our data model will give the wrong result, and if it will give the wrong result, then we will take the wrong decision. So now you must be asking that, so what is the next step once we get the skewed data in our data set? So how I can make our data set to remove the skewness from the given data set? Then I would tell that there are certain mechanisms, or say there are certain transformation techniques available. With the help of that, we can remove the skewness from the given data set, and those transformation techniques are, there is something called power transformation. We can convert our given data set with the help of power transformation. There is another mechanism that is called log transformation, and the third way is exponential transformation, that is used to convert our given data set to remove the skewness. But on top of these three, there is one of the powerful transformation technique is available, that is called Box-Cox transformation. With the help of that technique, we can remove the skewness and we can get our data ready to feed into the predictive model. And all these things are out of this course, as we are just learning the data analysis, where we are in a process to understand how our given data set is, what is the distribution of our data set is, what is the skewness within the data set, whether our data set is positive skewed or negative skewed. We are just learning those techniques. In the next part of this course, that is going to be predictive analysis course, where we will learn about all these transformation concepts in more detail. So now let's proceed further and discuss about another concept, that is called kurtosis. So guys, before discussing about the kurtosis, we have to understand there is a term called outlier. Then we will understand that why we are using kurtosis and what actually the kurtosis is. So guys, what is outlier? An outlier is an observation that lies an abnormal distance from other values. So suppose that if we are having a data set and if we are having some of the unusual observation that are far from the mass of the data, that point is often referred as outliers. So let's understand with an example what actually the outliers is. If you closely look into this diagram, then you will find that it is the representation or a scatter plot for XY data point, and here you will find that some of the observation residing very far from the mass of the data. Over here you will find that we have near about 5 outliers, which is very far from the actual mass of the data. So these data points which is far from the mass is called outliers, and outliers always affect the data analysis process. So it is always rule of thumb is that if any of the observation which belongs to the outlier category, we should remove from the data set, and then we will perform the data analysis, and then we will perform the predictive analysis. Because if we will feed the outlier data to the predictive model, then it will give us the wrong result. So that's the reason we have to perform the data analysis to identify the outliers. Now the question comes over here is, how do we can identify these outliers data point? Then kurtosis comes into the picture. So kurtosis help us to identify the outlier data point. We have three types of kurtosis. First one is the leptokurtic, second one is the mesokurtic, and the third one is the plateaukurtic. Mesokurtic is the representation of the normally distributed data. So that means our data set doesn't contain any outliers. Now if you talk about the leptokurtic, then this kind of shape will tell us that it contains the outliers. So if you go by formal meaning of the leptokurtic, then lepto means thin or skinny, and the leptokurtic distribution means there is a small change or less frequent data exist within the data set. Less frequent means the outliers, which is happening very rarely. In this case you will find that this data is happening very rarely, certain points occurring very rarely. In this case we are having two instances of those points. So now let's discuss about the plateaukurtic. So plateaukurtic distribution shows a negative axis kurtosis. So this kind of kurtosis reveals a distribution with flat tail, and the flat tails indicate that a small outlier in a distribution. And one thing I would like to tell you, plateaukurtic is very helpful for investors who wanted to invest. They also refer this kind of distribution plutocratic distribution while purchasing the share. If they find that kurtosis belongs to the plutocratic, then they will not do the investment in that particular share because there is a very small chances that the investment would experience extreme returns. And on this note, I am stopping over here, and this is what I wanted to discuss about in this session. See you in the next session. Till then, bye bye, take care.